Alright, you guys, well, we are back looking at Unit 2 review for the midterm. We're going to start just by looking at the odds of Unit 2. First of all, number 1 is asking for the figure in the pattern, the next figure in the pattern. If you notice, it starts off just by a single dot, then it goes to 2 by 2, and then 3 by 3. So my next figure is going to be 4 dots down by 4 dots across. And then you're going to fill in that square just like they've been doing. So it's a 4 by 4. Similar pattern here to number 3. If you notice, they're taking this single box and they are adding to it a row underneath it. That row underneath it goes one more to the left and one more to the right. So I see that single box from before on top, and then that second row adding out one on each side, and then they added another row, making that row one more block wider. So that next figure in the pattern should be this same pattern right here, except I'm going to add one block wider on the bottom, and then I'll fill in the existing blocks. So that would be my next figure, is this entire thing plus an extra row. You could also think of this as 1 in the first row, then 3 in the second row, then 5 in the third row. So that next row is going to have 7. Those are all odd numbers. 1, 3, 5, 7. So the next figure would have a row of 9. Number 5, you're looking for the next number pattern, and then you want to describe what kind of pattern it is. I notice that I've got 1, 1, 3, and then my next two numbers are 2, 2, and then 4. Then I've got 3, 3, 5, and then 4, 4, 6. And so the next two numbers I'm going to have are going to be 5, 5. The reasoning is here you've got 1 and 1, then 2 and 2, then 3 and 3, then 4 and 4, then 5 and 5. And if you notice, that last digit is increasing by 1, and so I'm going to increase that last digit by 1, and you get 5, 5, 7. You could also look at this just by adding 111 each time. You can improve that pattern. So 224 plus 111 gets you that 335. That's probably the more mathematical way to look at it. So you're adding 111 each time. I'll look at it very numerically. Number 7, we're going to look at how much we are adding again. How do you go from 1 to 4? Well, you add 3. How do you go from 4 to 9? You add 5. How do you go from 9 to 16? You add 7. So if you notice, we are adding odd numbers. 3, 5, 7. So the next pattern would be to add 9. 16 plus 9 is 25. So that's the next figure in my pattern. And you are adding consecutive odd numbers to figure out that pattern. Okay? Some good rules of thumb: if you are increasing in numbers, then you are probably using multiplication or addition, or even maybe a number squared. Those are all ways to increase your value. If you are decreasing, then you might be dividing by a number or subtracting. So those are some things to keep in mind when you're looking at a pattern. The next part of Unit 2 was all about writing conditional statements. Keep in mind, a conditional statement has an if and a then. If the hypothesis, then the conclusion. So number 9, if I'm looking to write this in if-then form, then what I want to do is start off with if and then my hypothesis. The statement says it is time for dinner if it is 6 p.m. So if it is time for dinner, then my conclusion is that it is 6 p.m. So here it's asking me to underline the hypothesis. Well, the hypothesis is it is time for dinner. The conclusion is it is 6 p.m. Notice in your hypothesis, you do not include the if, and in the conclusion, you do not include the then. If you look at number 13, it says write the converse, inverse, and contrapositive. Converse, I always think switch. Inverse, I think not, like the letter N. Contrapositive, you switch and not. Hopefully you'll see what I mean. So you've got your hypothesis here. You like hockey. Then you've got your conclusion here. You go to the hockey game. So if I'm going to switch them, then I'm going to take my conclusion and put it in the place of the hypothesis. I'm going to take my hypothesis and put it in the place of the conclusion. So if you go to the hockey game, comma, then you like hockey. You're just switching the two. Inverse, you're going to not both of them. So you go back to your original and you not. If you don't like hockey, then you won't go to the hockey game. The won't and the don't, those are the nots in there. Because it's do not, won't, will not, that sort of thing. Contrapositive, you want to switch and not. And so what I like to do is go back to my converse, and I just like to add the not in there. Then you won't. Okay? If you don't go to the hockey game, then you don't like hockey. Moving on to problem number 15. It tells us to write the converse, so I know I'm going to switch the hypothesis and the conclusion. If the converse is also true, then I'm going to combine the two statements and write a true biconditional statement. Biconditional is where I add if and only if. Number 15, if an angle measures 30 degrees, then it is acute. The converse is if it is acute, then an angle measures 30. Well, let's think about that. If an angle is acute, does it have to measure 30 degrees? No. Acute angles are less than 90 degrees, and so there's a lot of different things they could equal besides 30 degrees. So because this is false, that means that I cannot write a biconditional. You need both the original and the converse to be true. So I just skipped this part here. Let's look at number 16. If two angles are supplementary, then their sum is 80. That's 180. That's probably 180. So that's true. Then I want to write the converse, where I switch the hypothesis and conclusion. If the sum is 180, then the angles are supplementary. That is also true. If you have two angles and their sum is 180, then their angles are supplementary. Because they're both true, I can combine them to be a biconditional. So what I'm going to do is take the original statement And instead of having an if in the beginning and a then in the middle, I'm going to take the original statement and just insert in the middle if and only if. So my biconditional says two angles are supplementary if and only if their sum is 180 degrees. Just a few more here. True or false? Three non-collinear points determine a plane. True. You define a plane by any three non-collinear points. Number 19, through any 2 points there exists exactly one line. True. You have to have 2 points to make a line. Hence, any 2 points, there's going to be exactly one line that can go through there. The next section is on properties. Multiplication property of equality says if I have RS equals a TU and I multiply X times RS, then I have to multiply X times TU. You can multiply each side by the same thing and it's still equal to each other. The transitive property you'll see a lot. I think transitive takeout property. So if you have A equals BC and BC equals DE, then you can take out what they have in common and set the other two pieces equal to each other. So you get A equals DE. That's your transitive property. Number 25, we have to apply what we know about supplementary angles, complementary angles, that sort of thing. I'm going to use the same diagram for two different problems, and they're going to have different numbers. So I'm going to do this in pencil so I can erase between problems. Number 1, measurement of angle 1 is 53. So I'm going to label that. I have to find angle 2, 3, 4, and 5. The first thing I notice is that this line right here, we'll call that line L, and this line right here, line M, are perpendicular because they make that 90-degree angle. So what that tells me is that my 90-degree angle is here, and then it's also here, those complementary angles, as well as here, because this 90-degree is vertical to angle 3, so angle 3 is 90. And then 4 and 5 are also going to be complementary because of that right angle. Then I'm going to look at vertical angles. I know vertical angles are right across from each other. So this angle 1 is directly across from angle 4. So that's 53. In order to solve for angle 5, I know that 53 plus angle 5 has to equal 90 because of this 90 degrees. So 90 has to equal 53 plus angle 5. We'll call him x. So in order to solve, I subtract 53 from both sides. And you get x is going to equal, what is that, 37? So angle 5 is 37 degrees and angle 2 is 37 degrees because they are vertical. I'm going to erase and apply these same principles to the next angles. I'll go ahead and record my answer here. Angle 2 is going to be 37. Angle 1 is going to be 53. Angle 4 is 53. And angle 5 is 37. Then I'm going to erase because my next problem is using that same diagram but with different numbers. And I'll go ahead and use pen on this one so you can see it a little bit better. This time I start out with angle 5 is 39. And I'm going to apply those same properties. So the first thing I want to do is look vertical angles. So this one's 39. I know that 90 is directly across from the angle 3. So this one's 90 still. And then to find angle 1, I can add Angle 2 plus angle 1 and set it equal to 90 because those are complementary. So angle 1 plus that 39 degrees has to equal 90. Subtract 39 from both sides, and you get angle 1 is equal to 51. Okay, so angle 1 is 51 degrees, and angle 4 is 51 degrees. So I'm going to record my answer. Angle 3 is equal to 90. Angle 4 is equal to 51. Angle 5 is 39. Angle 1 is 51. And angle 2 is 39. 39. Almost finished for today. The next section tells me angle W is congruent to angle Z. So if they're congruent, then that means I get to set them equal and solve for x. So 11x minus 8 equals 9x plus 4. And you're just going to solve for x algebraically. Subtract 9 both sides. 11x minus 9 is 2x. Still have that minus 8 equals 4. From here, add 8 to both sides. You get 2x equals 12. To solve for x, you got to divide by 2. You get x equals 6. Okay? That's all it asks for, so I know I'm done. Last one in Unit 2 that I'm going to work for you tells me angle ABD, A to B to D. This angle right here is congruent to angle DBE, this one right here. It also says it's congruent to this one right here, EBC. Okay? So all of those angles are going to be the same. And I know that all three of those angles add to equal 180 because they make that straight line. So if all three angles add to equal 180, then what I can do is take that 180 and divide it equally between all three angles. 180 divided by 3 will be 60. So each piece here is going to be 60. So I take that 14x minus 10 and set it equal to 60. 14x minus 10 equals 60, so you add 10 to both sides. 14x equals 70. And then from there, you divide by 14. 70 divided by 14 is 5. So you get x equals 5. That's all it asks for you to solve for. Well, guys, that's it for Unit 2 midterm review video. Hopefully that'll help you get the rest of your problems done.